The smallest and nearest planet to the Sun in the solar system is Mercury. The quickest of the Sun's planets, its orbit takes place in 87.97 Earth days. Mercury, like Venus, orbits the Sun as an inferior planet within Earth's orbit, and as seen from Earth, it never seems to be farther away from the Sun than 28 degrees. Due to its close proximity to the Sun, the planet can only be seen in twilight, usually towards the western or eastern horizons after sunset or before sunrise. It may seem as a bright star-like object at this time, although it is trickier to observe than Venus. Similar to Venus and the Moon, the planet exhibits the full spectrum of phases through telescopes from Earth, and these phases repeat over its synodic period of roughly 116 days. In the solar system, Mercury revolves in a manner that is exceptional. It rotates on its axis precisely 3 times for every 2 rotations it makes around the Sun because it is tidally locked to the Sun in a 3:2 spin orbit resonance. It appears to rotate only once every 2 Mercurian years as viewed from the Sun in a frame of reference that rotates with the orbital motion. Therefore, a Mercury-based observer would only see 1 day every 2 Mercury-based years. The tilt of Mercury's axis, which is roughly 130 degrees, is the smallest of any planet in the solar system. Mercury's orbital eccentricity is the highest of all planets known to exist in the solar system. At perihelion, Mercury is only roughly 2/3, or 66%, of the distance it is at aphelion. The look of Mercury's surface, which is comparable to the Moon's and appears extensively cratered, suggests that it has been geologically dormant for billions of years. Surface temperatures in the equatorial areas range from 100 K, 173 degrees Celsius, 280 degrees Fahrenheit, at night to 700 K, 427 degrees Celsius, 800 degrees Fahrenheit, during the day, exhibiting the greatest diurnal variation of any planet in the solar system. The polar areas are perpetually colder than 180 K, or 93 degrees Celsius, or 136 degrees Fahrenheit. There are no known natural satellites of the planet. Mariner 10 passed by Mercury in 1974 and 1975, and Messenger, launched in 2004, orbited the planet more than 4,000 times over the course of 4 years before running out of fuel and crashing on the planet's surface on April 30, 2015. Mercury will be visited by the Bepi-Colombo spacecraft in 2025. A solid, iron sulfide outer core layer, a deeper liquid core layer, and a solid inner core layer appear to be the structure of Mercury's crust and mantle. At 5.427 G/cm3, the planet has the second highest density in the solar system, only behind Earth's density of 5.515 G/cm. Mercury's composition would be denser than Earth's if the effects of gravitational compression were to be taken into account, with an uncompressed density of 5.3 G/cm3 compared to Earth's 4.4 G/cm. The density of Mercury can be utilized to deduce information about its internal structure. Mercury is much smaller and its interior parts are not as crushed, despite the fact that Earth's high density is significantly caused by gravitational compression, particularly at the core. Its core must therefore be substantial and abundant in iron for it to have such a high density. Based on internal models limited to be consistent with the value of the moment of inertia factor given in the info box, the radius of Mercury's core is predicted to be 2,030 kilometers, 1,255.19 miles. As a result, the core of Mercury takes up around 57% of its volume, compared to 17% for Earth. Mercury may have a molten core, according to research that was released in 2007. A silicate-rich mantle measuring 500 to 700 kilometers, 310 to 430 miles, surrounds the core. Mercury's crust is thought to be 35 kilometers, 22 miles, thick based on information from the Mariner 10 mission and Earth-based observation. However, based on an area isostasy model, this model may be an overestimate, and the crust may actually be 2611 kilometers, 16.6 miles, thick. The surface of Mercury has a number of long, narrow ridges that can be up to several hundred kilometers in length. These are assumed to have formed when Mercury's core and mantle cooled and constricted, after the crust had already solidified. Many theories have been put up to explain why Mercury's core has more iron than any other major planet in the solar system. The most widely accepted explanation states that Mercury once had a mass roughly 2.25 times greater than it does now, a metal-silicate ratio comparable to common chondrite meteorites, assumed to be characteristic of the solar system's solid materials. Mercury may have been impacted by a planetesimal that was several thousand kilometers large and around 1/6 Mercury's mass early in the solar system's existence. The core would have remained as a reasonably significant component after most of the original crust and mantle were taken away by the collision. The huge impact idea has been put up as a theory to explain how the Moon formed. Mercury was discovered in 1974, making it the last planet to be discovered when humans first began sending spacecraft out to explore the solar system. This order may seem a little strange given that the closest distance between Earth and Mercury is 77 million kilometers, making it the closest planet to us on average. Mars was next visited in 1965, followed by Jupiter in 1973, and then Mercury in 1974. According to Chen Huanyin's model, a spacecraft would orbit the Sun about 15 times, passing by the Earth once, Venus twice, and Mercury 3 times before slowing down enough to enter its orbit on the 4th pass. All of these planetary flybys would be necessary because by skimming the planet's atmospheres, vital speed could be reduced due to atmospheric drag, and because of the planet's gravity, the entire route would cover a massive 7.9 billion miles. Only 1.8 meters long, 1.3 meters wide, and weighing 100 kilograms, the MESSENGER, or the Mercury Surface Space Environment Geochemistry and Ranging Probe, was small. For a normal NASA mission, this is compact and lightweight. The 20-meter-long Juno MESSENGER is outfitted with a strong thruster and a ceramic heat shield to shelter it from the Sun, a complete set of scientific tools for imaging and measuring data from Mercury, 2 solar panels, and in order to learn as much as they could about the chemical makeup of Mercury's surface, its geological history, its magnetic field, and its core, scientists intended to make the most of this opportunity. Scientists could test MESSENGER's equipment on a known astronomical body to make sure there were no errors and to make any necessary adjustments. MESSENGER took some photos of Earth and the Moon and also tested its other equipment to take readings of our atmosphere and magnetosphere. Fortunately, everything was working. MESSENGER spent its first year in space making one orbit around the Sun before meeting up again with Earth. MESSENGER entered safe mode, which was intended to safeguard the craft's systems in case of error. MESSENGER remained in safe mode for what must have been 7 hours of stress for all the scientists involved because MESSENGER had to pass through Mercury's shadow during this flyby, which required it to rely on its batteries for 18 minutes. Fortunately, something wasn't configured properly in the power management part of the software. Being too close to Mercury was too hot for MESSENGER, even with its heat shield, which was more designed to protect it from the Sun. The Sun is 7 times brighter by Mercury than it is on Earth, so moving further away allowed MESSENGER to remain cooler. MESSENGER took up an elliptical orbit around Mercury, alternating between as close as 200 kilometers and as far away as 15,000 kilometers. Scientists had originally intended for the mission to last only 1 year after launch, but MESSENGER spent the following 4 years in Mercury's orbit, far exceeding their hopes and expectations. Scientists had hoped that MESSENGER would take at least 1,000 photos over the course of its lifetime, but MESSENGER took over 200,000 photographs, providing us with a complete map of Mercury's surface in high resolution and color, as well as photographing Mercury's atmosphere. MESSENGER's trip has come to an end. If you are interested in learning more about the mission's scientific discoveries in a future film, please let me know by commenting or liking the video. I think this is an intriguing topic, and I hope you do too. Thanks for watching and don't forget to like and subscribe.